Hello everyone, greetings of the day. Welcome you all for the 12th video of learning Swift programming language. These are the topics that we have covered from the video 1 to video 4. Here I have listed from video 5 to 8 and video 9 to 11. Let's move towards the today's topic. The first topic that we are going to see is importing framework. This allows to access functionalities and features provided by external libraries or modules. That is, Swift itself provides a group of functions, classes, variables that is organized for people to include in their projects using import keyword. Already a set of functions has been defined somewhere and we can use that into our project. We don't want to write from the scratch. Already these things have been written and kept for our users by the Swift itself, so that we can just import that names frameworks here in our project and we can write our projects. See here we have imported a framework called UI kit, that is in order to the use of user interface components like buttons, labels, table views, text fields and more, we need to use this UI kit framework. Like that, we have foundation framework as well. That is for the usage of basic data types, networking and more. As the foundation is the integral part of Swift, it is automatically imported into every Swift file by default. Thus, the core functionalities are readily available without importing the foundation framework. See, without importing this foundation framework, we can use strings, arrays, dictionaries and more. But for the advanced features like networking, we need to import this foundation framework. So these are about importing frameworks. The next topic that we are going to see is how to connect components in storyboard to view controller. In order to access the components in design file, that is main.storyboard, to the code file, that is to the view controller, we need a connection between the storyboard and view controller. Let's see how to do this in Xcode. See, in this project I have created a view in the main.storyboard and running the project as I designed. I am showing in the simulator here. If I want to access the property of this view without touching the storyboard from the Swift file, means I need to provide a connection for this view to this Swift file. Let's see how to do that. See, I have a view controller here. If I need to add another Swift file, I can right click on the project here and click on new file. Here I can go with the Swift file or CocoaTouch class. So I'm going with the CocoaTouch class. It's asking for a name. I'm providing as test view controller and make sure this box is not checked. And it is a class of UI view controller and I'm clicking on the next. It's saving in our project. If I click on create, a new Swift file will be created. We can keep the Swift file here. The name of this is test view controller. Again, I'm going to the storyboard and when I click on this view controller and checking from the identity inspector here. This view controller is assigned to the class name of view controller, that is here. Now we need to change this to test view controller. This I am doing for an understanding. So now changed this test view controller. Okay. Now with the help of this assistant editor, if I click on this, we'll be getting the two screens and I'm moving one screen to this Swift file and the another screen to this storyboard. I want to make a connection of this view here. So above this view did load, I am providing the connection. So I can click from here or in the design file and then control drag. After pressing control, I am dragging that here. Immediately it will ask for a name. I am providing as test view label. See how I have labeled here. The first letter need to be small and then the view V need to be capital and again the label L need to be capital. This way of providing name is called camel casing. So in every programming we need to follow this. Test view label, and if I click on the connect, this outlet is connected here. So if I hover over here, I can say that this test view label is connected in the storyboard here. If I want to check this in storyboard, I can check it from the, see, I have clicked this and from this connection I can show it. See, this test view label is connected to the test view controller. So here we can see the connection. And if I need to change the name of this variable, means we need to right click on this, refactor, rename. After that we need to rename this one. We should not directly change something here and we should not change the name. We need to do the refactor rename. After that only, if there is any editing, we can provide here and click on the rename. And see, with this IB outlet, I can access and modify the properties of this label of this view programmatically in code. See here, test view label. I'm accessing the background color. I'm changing the background color from white to red. If I run this in simulator, here I have designed it for white color. I'm changing programmatically to red by creating an IB outlet. See here. Previously I have designed and the simulator is the same. Now I have made a connection using this IB outlet and changing programmatically. See here, text view label dot background color I am changing programmatic to red, and in the simulator also it is changed. So this is the purpose of IB outlet, providing a connection from the storyboard to Swift file. Similar to this IB outlet, we have IB action as well. That is used to create a method that responds to UI events. If we have some buttons in the simulator in our application, if we click on that, something need to happen. That we can see now. See, I have only the view here, so I'm going to add a button now. So I'm just adding the button here and providing an outlet and action for that. Same control drag, I'm saying as sample button. This is an outlet, and if I need to create an IB action, I need to create below this view did load. The same thing, control and then release button clicked. See here, the connection is action. If I need to change this to outlet, I can change like that. And then here the event, it is mentioned as touch up inside. Here there are so many options available, but the default is touch up inside. That is, if I touch that button, something need to happen. I'm clicking on connect. So if I click on this button, I want test view label background color need to change to green, and then here I'm provided the title of this button as button. Now I'm changing, that is sample button dot set title. Here we have provided a title. I'm mentioning a sample and just providing the normal. So if I run this, I'll be getting that. See here, I have added a button here, and the title of this button is button, and then the view color is red. If I press this button, this action will happen. See, if I press, the text changed to sample, and then the color of this view changed to green, as we mentioned here. This is the IB action. In IB outlet, we are accessing and modifying the properties, but in IB action, it's typically associated with events such as button tap or value change in slider. When we create an action, we are defining a method that gets triggered based on event. So in order to create IB outlet and IB action, first of all, we need to make sure that from the storyboard, here this is assigned to the class. After that, each component from here we can control drag to the code in order to make connection. If we want to disconnect, we can disconnect from here. That is, I'm disconnecting this test view label. I can disconnect like this. If I need to connect back from the code to storyboard, I can option click like this. That is, from the storyboard, in order to connect to this class, we can control click and drag. But in order to do the opposite, we need to go for option click. And if we need to change, edit any names here, we need to go for refactor rename. IB outlet is for changing the properties, that what all the properties we are changing here, it will affect in the application. But for this button click, what all we are doing here, that is the interactions that we are doing in the simulator or application, after that this method will work. The next topic that we are going to see is alert and action sheet. Alert is a pop-up that will come in the center of the screen if we need to get notified about something. Action sheet is a set of options that slides up from the bottom of the screen, and we can click on whatever the options we have required. Let's see this in code. First, we will see about the alert. I have used the same previous example here. Whenever we click the button, previously I have set up that the background color of this need to change to green, and then this title of button need to be changed to sample. So I'm commenting out now. I'm not using that for now. Okay. Now if I click this button, I need to pop up an alert. So I'm setting up the alert here. So initially I need to do the alert controller. I need to define here first. And what is the title of the alert need to be. So if I click this button, see alert title. So this is the alert title that I have provided here. And then what is the message I need to display. This is an alert message. And the preferred style I have been selected as dot alert. You will be seeing that when I explain about the action sheet, this preferred style will get varied. And after that, add an action button. This action button is this OK. That is what need to happen when I click on this. I have only one action button here. If I want OK or cancel, or like that means we can provide two action buttons here. So here the same alert action I'm defining. The title need to be okay, style need to be default. After that, I'm adding a closure here. Here I'm defining that what need to happen when I click on this OK button. After that, I'm adding this OK action into this alert controller. That is, I have defined an alert controller here. After that, individually I'm defining this OK action button. After that, I'm adding that here. And the overall alert system, here I'm presenting it. See what happens when I click on this OK button. So the OK button tab will be printed in our console. If we want something other need to happen, we can define in this curly braces. So if I click on OK, I can see that OK button tapped. Again, if I press the alert title, title message, preferred style is alert, and then I need to have here only one action button, that is only OK I needed here. So I have defined that, and what need to happen when I click on that OK button, that I have defined here, adding that OK action into this alert controller, and I'm presenting here. So if I click on OK, OK button tapped will be printed in our console. Now with the same example, I will explain here about the action sheet. Before this, when I press this button, I'll be getting a pop-up of alert. See, I have defined an action sheet here. The same alert controller, title I have defined, message I didn't provide anything, and the preferred style. Before this, we have seen that the preferred style I have been mentioned as alert. Now I'm providing as action sheet. And then what are the actions that need to have? Before this, we have only one actions of OK need to be there, but here I have been kept as option 1, option 2, and then cancel. 3 action button I have been kept, and what need to happen when I click on that? If I click this inside this closure, it will be printed as option 1 selected. Here option 2 selected, and here I didn't provide anything on this cancel. After that, I'm adding that action into this action sheet. Into this action sheet, I'm adding these actions. After that, I'm presenting here. See this in simulator. So if I press on this button, I'll be getting a sliding options, and we'll be getting like this. So this is the action sheet. Previously we have seen the alert, and this is the action sheet. So this select option, I'm defining here select an option. After that, the preferred style is action sheet, and then I'm defining the actions here, option 1, option 2. So what need to happen if I click on option 1? See, if I click on option 1 selected will be printed in our console. Option 1 has been selected. Again, I'm pressing the button. If I click on the option 2 selected, that will be printed in the console. If I click on cancel, this is the default thing. If I click on cancel, nothing will happen. Okay, so these actions I have been added to this action sheet and presenting here. This is the alert and action sheet in Xcode. The next topic that we are going to see is Segue and navigation. See, if we have multiple screens in an application, we need to transit from one screen to another. In that case, we need to have segues. Let's see this in Xcode. See, in this view controller, we are having one screen. If we need to add another screen from the object library, we can. Initially, we have added view. Now, we need to add the view controller. See, we have view controller here. Just need to drag and drop here. So, we have designed one screen here and another screen now. I'm just adding an background color for this from the attribute inspector. I'm adding a background color like teal color I'm providing. As I informed, this arrow indicates the entry point into the application. Suppose if we deleted this, in order to bring back, in order to provide which one is the first screen. We just want to click on this view controller and select is initial view controller. Then it will replace here. Now I want to show that if I click on this button, then it need to go to the next screen. For that, I can select the button from here or here and then control drag to the screen. If I release this, it will ask options. So these are the presentation models, how the next screen need to show. Based on our application needs, these may get vary, but the step is similar. I just want to present it as show, that is push. The next screen will get pushed to this initial screen. So I'm just pressing for the show. And already I have added some code for this. I'm commenting out that. So in this case, nothing will happen from the code because I have added the segue in the storyboard directly. So when I click the button, it need to navigate to this second screen, and I have mentioned the presentation style as show. That is, it will push the second screen. So if I click on this button, this is what it is happening. The second screen is pushing into the initial screen. If I want to come back to the initial one, I can do like this. If we have navigation bar, it will be providing with the back button. From the back button, we can reach to the previous screen. So this is the segue that we have added using the storyboard. The same segue we can do with the code itself. Let's see how to do that. Before that, as I mentioned, I need to provide this segue an identifier because we will be having multiple screens. Each segue will be provided with the unique identifier. So we will be checking that if that identifier matches, then only we will allow the transition. So that for every segue we need to provide an unique identifier here. See, now I'm handling the segue from the code section. So I'm deleting the segue now, and then initially I have connected this button, that is one of the component I have taken and added the segue. But while doing from the code, I'm doing that from this view controller. Again, I'm making the control drag to this one and mentioning as the presentation style as show. So in this case, when I select the segue, the entire view controller, I'm making a relationship to the next screen. So I'm entering an identifier here. I have mentioned as go to second screen. So I'm copying that. So this is the button click. So if I click this button, something need to happen that I can enter here. I just want to mention as perform segue. So here perform segue with identifier. This is the identifier that we have provided already. So I'm just pasting. So we should not have any typo here. This need to be exactly the same thing that we have mentioned for that identifier. So this is a one line code. Perform segue with identifier. This is the identifier. In the center we can mention as nil. If I run this, and while clicking on the button, the same thing will happen, but in this case I'm handling it from the code. See, the same thing happened, it goes to the second screen, but this time we have handled that section from the code. See, another scenario here, when we move from the screen 1 to screen 2, we need to carry some information from the screen 1 and that need to shown in the screen 2. Let's check that scenario here. I have added a text field. from the show library, I have added a text field here and I have connected that in the name of text area to this text view controller. And then I have added a variable here with the user entered data. What I'm doing is when I'm clicking on the button, the user entered data assumes the value of the text area dot text. Here if I entered any text, that will be entered into this user entered data and I'm performing the segue. But before performing the segue, one thing will happen, that is prepare for segue. We have this prepare for segue, that is this function is a default provided from the Xcode. Before performing this segue, if we need to pass any data from this screen to the next screen, we can send it from here. That is inside this function that we are checking that if segue.identifier, that is we may have multiple screens as I said before. So in that case, we need to exactly match with the identifier that we are moving. If the identifier is this one, go to second screen. If it succeed, we'll enter here and we are defining a destination VC constant. That is, if this segue got succeed and it enter the second screen and that destination is second view controller, means if there is a screen called second view controller, we are setting it as a destination and providing the name as destination VC. After that it will enter here, then only we can able to access the properties mentioned in the second view controller. See here, if this got succeeded, we are accessing the property with the name of the constant declared here. So the destination VC dot user entered, this is the property. This is the property I have declared here. This is the second view controller, that is here. For this view controller, I have added another code, that is the second view controller and assigning. In this second view controller, I have a variable, that is the user entered, and a text label. So see, this is a text label and I'm mentioning that this text label dot text equal to this user entered. So I want to pass the data from the first screen to this user entered. In that case, when I reach the second screen, the text label dot text will get replaced with this user entered. So here destination VC dot user entered equal to user entered data that I am getting from here. So when I click on the button, immediately it will assign the text area dot text to this user entered data, and before performing this segue, here this will happen. Here I am checking that if the identifier of the performing segue is this, means it will enter here, and again setting a constant for destination VC as this class. In that case, I'm accessing the variable of this second view controller and assigning this user entered data. After this, the segue will happen. See, this is the first screen. So I'm mentioning this and clicking on the button. So immediately it will replaced here, because in the next screen I have just mentioned the text label. It will get replaced with the text what I have entered. If I am deleting this, enter another text, if I am clicking on button, it will get replaced. So this is the prepare for segue. Segue we have seen in two ways, that is one with the storyboard and then with the code, And while doing with the code, if we want to transfer any data from the first screen to the second screen, we need to do the prepare for segue. Inside this prepare for segue, we are first checking the identifier. After that, declaring a constant. With that constant, accessing the variable and transferring this data. In the next screen, that is in the second screen, I have just made a text label and then a property here in order to get data from the first screen. While it load, I'm doing that text label dot text. That is, this text label will be replaced with the user entered data. This is the segue and navigation. Before this, we have seen the transition from one screen to another with the help of segues. Now we need to understand about the life cycle of view controller. Let's see this in code. Before explaining the life cycles of view controller in detail, I just show a demo here for understanding. So I used the same example as before. We have a text field here named as text area, and when the screen loads, it will be written in default as the enter text here. That is the text area dot text. I have mentioned as enter text here, and we have a button as well. So when we type something here, and click on the button, and the next screen it will display what I have entered. See, and I have added a nav bar to this, and when I click on the back button, the initial screen where I left will be showing. See what I have written, new word I have written before leaving the screen, the same thing is showing now. The same scenario I will explain with the view will appear. See, if we have view will appear and I'm entering this code in view will appear. If I run the simulator again, you will see the difference between this view did load and view will appear. Same happened, right? In the first screen, enter text here that we are showing, and I'm altering some text here. If I click on the button, what I have entered will be showing. When I click on the back button, then you can see the difference. If I click on the back button, see, again it came the enter text here. In the previous thing, what we have seen, where we have left, it is shown. That is, if I enter a new word and click on the button, it will go to the second screen, and when I come back to the first screen, the same word that I entered will show. But when I do with this view will appear, every time when I go and come back, the enter text here will show. This is because of the life cycle. Now let's understand in detail about each life cycles. We can categorize the life cycle of view controller into 5. That is, the first one is view did load. As I defined, this is the view controller's view when it is loaded into memory before it appears on the screen. That is what this view did load is working. And the most important thing is these view did load, view will appear, view did appear, view will disappear, view did disappear. These life cycles methods all, everything will be called automatically by the Xcode. We don't want to explicitly need a calling function for this. And this view did load will be called only once during the lifetime of a view controller. This is what we have seen in the previous example I have explained, that enter a text here. That method is called only once. When I switch to the other screen and while I come back, that is not there. This is because view did load will be calling only once during the lifetime of a view controller. We can use this for fetching data or setting up the UI elements. For these and more, we can use this view did load. The next one is view will appear. This will be called before the view is about to be displayed on the screen. That is, before it is displaying on the screen, this method will be called, and it will be called every time when the view is about to become visible. This also I have explained in the previous example, that initially the enter a text here was there, and after that when I switch to the next screen and when I come back again the enter a text here was there. This is because it will be called every time the view is about to become visible. For updating data or UI configurations we can use this. The next one is view did appear. This will be called after the view is presented on the screen. That is, after we can see the screen, this method will be called, so that this can be used for starting animations. If we use in the view will appear or view did load, that and all will happen before the screen loaded. That is, we before we are seeing that screen, those methods will be called. So while we start animations there, before we see itself, the animation will begin there. So that for animations kind of things what we are adding, this is the best place. View did appear. The next one is view will disappear. This will be called when the view is about to disappear. It is not gone, but the view is about to disappear. In that time, view will disappear will called. This is for cleanup task, or if we want to, if we are typing a long form or something in between, if we are going out, if we need to save that form, we can do here. Otherwise, if there is a lengthy form, if we go out and come back, we need to type that form from the beginning again. So here we can add the methods for functions, like for saving forms, or if any cleanup task or the, we can enter here in this view will disappear. This view did disappear is the final thing. After this view has been disappeared from the screen, this will be called. Again, this is for additional cleanup or to stop. See here we have started some animations, right? So in this place the screen will disappear. So what we have started in the view did appear, we can stop here. Like if there is any animations we have started in the view did appear, we can close it in this, or we can stop this in view did disappear. So these are the 5 methods of life cycles. The usage of these life cycles will vary based on the projects what we are working. If you have the basic understanding of this, then you can add multiple things into this and configure or customize your project. With this, we are wrapping the session for today. Thank you.